In this session, we will discuss about point-to-point link, link power budget, and raise time budget of optical communication system. The point-to-point link has transmitter at one end and receiver at another end, and transmitter and receiver are connected with the help of optical fiber. While designing a transmitter and receiver, the components are chosen carefully in order to meet the desired performance of the optical communication system. The important component in the design of transmitter is optical source. Optical source can be a LED or laser. While choosing a optical source, the following characteristics must be taken into consideration. One is signal dispersion, second one is data rate, third one is the distance to be transmitted. Similarly, in the design of receiver, a photodetector plays an important role. The choice of photodetector is based on the following parameters. One is responsivity, second one is operating wavelength, third one is speed and sensitivity, and the transmitter and receiver can be connected with the help of optical fiber. Optical fiber can be a single mode fiber or multimode fiber. In the multimode fiber itself, there are two subclassifications are there. One is step indexed fiber or graded indexed fiber. This choice is based on the amount of distance to be transmitted and dispersion. Link power budget is the estimation of how much amount of transmitted power is required in order to make the optical communication system more viable. While calculating the link power budget, the connector loss and splice losses are taken into account. Link power budget estimates the total loss allowed between optical source and photodetector. While calculating this one, the following losses are taken into account like cable attenuation, connector loss, splicer loss, and system margin. The total power loss in the link is given by PT equal to PS minus PR. PT is the total loss in the system. PS is the optical power emerging from the end of fly lead, and PR is the receiver sensitivity. Further, this can be written as 2 into LC plus alpha F into L plus system margin, where LC is the connector loss and alpha F equal to fiber attenuation in decibels per kilometer, where L is the transmission distance between source and load, and 6 to 8 dB of system margin will be considered in order to compensate the unaccountable losses in the communication system. The dispersion limitation of optical communication system is determined with the help of raise time budget analysis. The total raise time of a optical communication system is nothing but square root of sum of squares of individual components raise time degradation. Raise time is nothing but the time taken by the component or a system in order to respond to its input. The raise time and fall times of the components will determine the overall response time of the optical communication system. So hence the resulting in the final bandwidth of the system. The connectors, couplers and splicers do not affect the speed of the system. So their raise times are not taken into account while estimation of raise time budget. At four basic elements that contributes to the raise times are: one is transmitter raise time, second one is group velocity dispersion raise time, third one is model dispersion raise time of the fiber, fourth one is receiver raise time. These raise times are taken into account while calculating the overall system raise time. So T system equal to root T square transmitter system raise time plus model dispersion raise time plus group velocity dispersion raise time plus receiver raise time.